Good afternoon, everyone. Thanks for joining to our short webinar about Google language processing, as we call it. Basically, our idea is to present you some of the brief overview of how Google does NLP and what might be the reason for you or us to use their services to enhance our services. Maybe let me start with a brief introduction who we are and why we want even to talk to. So first, I'd like to give words to my colleague Brandon.
Hi, should I introduce myself?
Yes.
Okay, yeah, so my name is Brandon Eychaner. I'm from the United States originally, but I'm based in the Prague office in Czech Republic. I've been doing natural language processing there for the past 4 years, and recently have been elected to lead the generative AI practice within Central Europe. And so my specialization lies in information retrieval, information extraction from documents, and knowledge management, these kinds of use cases. And happy to be here. Thanks for having me.
Thank you, Brandon. So nice to meet me. My name is Philip. I'm also stationed here in Czech office. I'm a machine learning operations expert. My main focus is using those advanced AI-powered, let's say, services to work with human-generated content, such as intelligent document processing, process mining, chatbots, voice bots. And I really enjoy the technical stuff behind how the stuff works and how to deploy it to bring value to our clients. And last but not least, we have David. Can you introduce yourself, please?
Hello, everyone. My name is David Schopf. I'm also located in Prague, Czech Republic. I have a background in human-computer interactions. I've been designing, developing voice bots and chatbots for the past 2 years, and looking forward to the whole webinar and the questions at the end for you.
Thank you very much, David. So now that we presented ourselves, we'd like to know something about you. So we have a very short poll prepared for you. So if you can just tell us from what background you came here to us, basically, so we have some idea how overpowered we are during this webinar by your knowledge. So if you are already an accomplished AI or machine learning expert, so later on, please just leave a message and we'll come to you for help. Or if you are just an enthusiast, as we all are, about the current developments of generative AI, it's not only our specialist news are full about it, but news around the world. Or if you just thought that it might be interesting. So please, if you can fill our questions, fill our answers, so we've got some idea. Great, perfect, thank you. I can see that it's a pretty nice split about each of the categories. So we'll try to keep the discussion wide, so we can incorporate even the harder topics as well as the overall introduction. So speaking of that, let's jump straight to it. So if I may ask Brandon, if you can tell us what is NLP and why should we care about it?
Sure. So natural language processing is essentially a family of processing techniques and algorithms that deal with unstructured data, generally applied within the field of like language. So this would be like voice data, text data, documents, logs, anything where the data isn't stored basically in an Excel table, we consider unstructured data. And if it uses human language to encode information, it fits perfectly under natural language processing. And I have like a nice little historical slide here. I'm not going to read this to you, but I just want to go over some foundational concepts that will help you to understand sort of the current way that natural language processing is done, especially in regards to generative AI and why it's so powerful and how it's gotten here. So originally, the field of natural language processing was referred to as like computational linguistics, which is where you try to turn language into math, if I needed to put it in one sentence. So the way that you can do this originally was just by counting the number of times that a word is mentioned in a text. You divide it by the total number of words in the document, and you get a concept of like how important words are to specific documents. That was the n-gram sort of approach to encoding natural language in a way that computers can understand. After that point, we got to like word-to-vec models, which use large amounts of text that are run through machine learning algorithms in order to get a sense of the statistical distribution of words in their contexts. So instead of just having a count of the words, you also have statistical information about how that word occurs in different contexts, whether it comes before or after a negation in the sentence, and you have a more powerful representative representation of the meaning of language using these like vector models. And the outputs of those look like you have a sentence, for example, it goes through a model, and what you get is an output vector, or what we refer to as embeddings. So instead of having like a word, you have a representation of that word that's numerical. It's just a system of numbers. So then we're going to take that one step further. Once you have enough data to train one of these vector models on, the way that you process language can be then arithmetic, essentially, or the idea was that you can sort of represent words in this arithmetic way. So if we took the embedding or the vector for king, subtract man, and add the vector for woman, you get the vector for queen, something like this. So what this allows us to do is to measure the distance in meaning between two different words or two different texts. So then we fast forward a little bit more and we get to the transformer architecture, which is where things really started to take off. This is where we introduce the idea of attention and of directionality in the way that language is encoded. So the transformer architecture allows us to pay special attention to particular words in a series of documented series of sentences. And what happens is instead of just having a feel for like the meaning of a particular word, you actually have the meaning of the word that has now been perturbed so that you understand it in the context of the entire document. Or if there's one word that means multiple different things, you get a sense of which meaning this word actually does. And not just at the word level, but also at the sentence level. And this is really powerful for working with search functions. So if you want to search in English and get a similar returned vector in Spanish, for example, if you train a model, a transformer model on multiple languages, you get a similar statistical distribution and similar embeddings for similar words across languages, which is super powerful. And this is sort of where we super fast forward into the current models, which is where we get to the generative models, which I will get into later. But they are essentially all, at this point, based on the transformer architecture. So there's really powerful embedding methodology applied to multiple languages. So we can go to the next slide if you like. Okay, so, I think we may have skipped one. Yep, there we go, okay. So that's all the math stuff. I'll try not to get into more technical detail unless you guys have questions later. But the purpose of natural language processing is to turn unstructured data into something structured that you can use in downstream tasks. What this means is that instead of just having like doctor's notes or emails, or news articles that you would have to read as a human and try to extract information from it, you extract whatever information you need, like named entities, which are organizations, people, places. You can extract sentiment, so whether it's positively or negatively charged semantically, and you can sort of derive insights from this unstructured data and then use that structured output in some sort of downstream task. Which can be classification, it can be machine translation, or other machine learning algorithms. And we can go to the next one. And the nice thing about GCP is that all of these services live natively within their natural language processing offering. So this is everything from Vertex AI, which helps to host machine learning models where you have training data, you can upload your training data and then come up with a model on the other end. And part of the offering under GCP is like native integration with transformer models, BERT-like models, etc. And the NLP API also does all these other nice functions. So machine translation, speech to text, named entity recognition across multiple languages, etc. And I think we're going to go into more detail on that. So I'll hand it over to my colleague. Thanks.
Thank you for the introduction, Brandon. So as was said, right now we'd like to go more in depth in some of these offerings, because as you've seen, it was just a small part of the much wider picture of the GCP NLP services, but we'd like to talk about a few of those specifically, which we feel that are the most powerful, that are bringing the best value to the effort compared to the effort that's necessary for using them. So the first group, let's say, are the out-of-the-box working solutions, which basically requires no specialization on your end when you want to use those services. This is, for example, the translation API, which is basically the power of the web browser translator that we all use, love, and hate usually. Provided as a API, provided as a service. And the best part in it is that it's the same models behind it. As Brandon said, it's the same ensemble of the cutting-edge technology that's powering this machine learning translation, and it's provided not only as the browser-based window that we all use, but it's provided as a RESTful API. That means that you can integrate it in whatever service you need in your program, just as a simple HTTP request, and you can get your text translated. It has all the nice features that the web version provides. That's, for example, automatic language detection, that you do not need to specify beforehand what the language of the source data will be. You just need to specify, yeah, I want it in English in the end, but I'm not sure what my clients will paste in. So it's nice that this is available as well in the API. And the best part is that other than the base model that you can use in the browser, you can also have the customizable glossaries. That means that you can specify your domain-specific phrases and domain-specific words that you want to have translated in repeatable and in some special manner. For example, that in my experience, the issue often with machine translation is that here in Czech, we do not translate a lot of technical words. For example, if I would want to translate this presentation that we are showing to you, many of the technical stuff I won't have translated because it doesn't make sense. It's not used in the machine-like translation here in Czech. So I can specify beforehand in the API that all those technical terms I do not want translated. Next, I'd like to talk about the speech APIs. This is actually a bundle of text-to-speech and speech-to-text APIs that work in basically the same way. They are presented as a RESTful API, and then they provide a way to basically integrate voice inputs into structured data, as well as generate voice outputs from your own text. The best part about it is that these provide a real-time execution. That means that you can embed them in a lot of real-time application. For example, if you would like to have them implemented in your call center, for example, is a nice example where they can be used, because while you have the client on the call talking with your agent, you can in real time send the voice to the speech-to-text API that will generate the structured text out of it, and, for example, present a filled form for the agent to use during the conversation in real time. You do not have to wait after a conversation to send the results to the customer. You can do it on the fly. Again, what these services present on top of the many on-premise solutions is that, for example, for a text-to-speech API, you can use not only, I think it's more than 200 voices that are available, but you can use something that's called speech synthesis markup language to design your own voice for the specific use case you need. Because you can imagine that you want to have a different pitch of the voice, you want to have different phrasing when, for example, you are developing an application for some IoT smart home thing, and different pitch, different tone of voice when you are presenting something as a chatbot or voice bot. So those are the basic APIs that you can use out of the box without any domain knowledge, I'd say. One step further is the cloud native language service. Brandon already mentioned that you can access all those powerful NLP functions in GCP. You can perform sentiment analysis, that's extracting the nature of the conversation, how it flows, and assessing whether it's in positive or negative manner. Again, perfect use case for call centers. Named entity recognition to extract the other hard to get information from the unstructured text, because trying to parse out of the text some of the numbers, etc., that can be done in a traditional manner with regexes, etc. But if you want to get out names and company names and towns, that can be much more difficult if you do not want to have huge dictionaries. But again, the NLP model can assess that it's the object of the sentence and therefore extract it as a named entity. As well, classification is available, but the most powerful feature is AutoML, which basically combines the Vertex AI machine learning platform with the NLP capabilities, where you can paste your own data for your own use case, train the models without writing a single line of code, use all those cutting edge technologies with just providing your own data labeled, probably, to teach the machine what is your exact use case. For example, in the classification, maybe the base pre-trained category is tax form, but you want to be more specific. You want to separate tax forms from businesses and from persons. So you can provide a few labeled examples, and the machine will learn. And you can use this service same as the native services provided by the GCP. And the last offering we'd like to talk about is where we feel that this is brought together, and that's conversational AI, because we know that right now there is a huge abundance of chatbots, voice bots everywhere, but how Google does it feels special for us, because it brings all those separate self-contained services together inside one platform. It's called Dialogflow, and it basically uses all of these services we described previously to enhance the capabilities of the AI assistant that you build with it. As I'll show in a few minutes, the Dialogflow itself is a really simple, low-code visual environment. Therefore, you do not need to have a huge team of data scientists working on one single chatbot. It's drag and drop and very simple. Therefore, you can use it in your business to build a chatbots, voice bots much faster, iterate through the from simple concepts to much more complicated scenarios, and therefore provides a much better possibility to roll out finished products. And this is it for the bit more in-depth overview of those services. And now I'd like to switch to the demo. But before I show you how the chatbot in Dialogflow works, I'd ask David if he can give us some input on the motivation behind the AI-powered assistants, why we want to use them.
Of course, absolutely. Thank you, Philip. Thank you, Brendan. So as you've heard from my colleagues, the user experience is very important, and the move from IT-centric to user-centric has been quite prolific in the last years. We are trying to approach, or the big companies and Google especially is trying to use or provide user-friendly and usable technologies. What we really care about, or what Google really cares about, is the improved customer experience. So really providing the end customer with solutions that help solve their issues. What that means is what we can do, and you will see in the demo, is trying to support, not exchange human operators or human agents on one end, but support creates the environment for the companies to be able to provide best in the business solution and customer service. So we basically making better the services through technology by providing 24/7 services, by providing on-demand information, and overall trying to improve the satisfaction of the service. Together with that, it comes to increase efficiency and cost savings because you are able to automate certain flows. And usually from our understandings and from our experience, you can literally automate 60 to 80% of the incoming calls, of the incoming questions from the customers across the industries. So it's not industry specific, but it's really a generic claim that we can give that 60 to 80% of all the conversations, communication flows can be to some extent automated, which brings a lot of benefits, right? I've mentioned 24/7 support, but it also comes to the user experience in the end, because the more difficult queries, the more personal approach can be taken on the side of the human operators, because you are able to provide the basic information very easily for voice bots or chatbots, as Philip will demonstrate in the demo. Another benefit that comes with enhancing the experience with technology is that you receive a lot of data. That means it further helps you to develop your businesses, to have more insights how your customers are behaving, what is their demand, what they really want, and how you can further improve your services and their customer experience in the end, which drives the value of your business and brings you more customers and increases the revenues. In the end, it's also about scalability and consistency, right? Human operators are great. People who provide information are extremely useful, and it's super nice to talk to humans, but sometimes also them have bad days. Something happened in their family, right? They're not in the best mood, and you just don't have the consistency as you would have with technology that is kind of emotion resilient. In a sense, you always get the same outputs from them. With the same way, you can scale up much more easier with technology than with human operators, let's say, or human agents. It's much more easier to upscale or create a new scenario for a chatbot, or just increase the volume of incoming queries that the chatbot can handle, on the opposite to human agents. Back to you, Philip.
Thank you very much, David, for your insight. So as we already tantalized before, right now I'd like to skip to the brief demonstration of how the chatbots are actually built inside the GCP environment. And just a disclaimer, we all have interacted with in chatbots and voice bots in one way or another over past years. If you have had any issues with your internet at home, with your insurance company, whatever, you definitely talked with the machine. Therefore, I do not want to present you some already running chatbot somewhere, because we all know that it can be done. What I'd like to focus during this demonstration is to show you how easily it can be done on Google, that you definitely do not need to have huge expertise building those systems, and that you can start small start playing with it, and it's really simple doing the first steps, and then maybe the idea how to improve it comes to you, and you can work on that. But you can start with a pre-built solution without a need to invest heavily in the first iteration of the service. So I believe that you can see the Google console right now instead of the presentation. So what you can see is the Dialogflow console inside the GCP environment. You can see that I do not have any agents. They are calling the voicebot and chatbot agents. I don't have any created yet. So the first part of the demonstration will be creating just very simple, or using the pre-built very simple agent. So let's say I'll take from the pre-builds, I'll take the small talk chatbot, which doesn't do anything interesting. It just responds to your very simple queries with some usually a bit funny answers. So if any of you ever done anything on GCP, you probably can understand what's happening here. But if you haven't had experience with GCP, don't worry. It's not necessary for understanding what's happening. So right now I'm importing the predefined chatbot that has been developed by Google inside our environment. And here you can see that the flow is really simple. It just starts, it asks you something, and end the session. So if I just try to talk to the agent, so I just send a greeting, and yeah, you can see it. He greets me, and what I can help you. How can he help me today? So I'll ask him something. I don't know. I'll paste some question, and yeah, he responds with one of the predefined answers. So let's dig a bit deeper into how he's responding. What's happening here? So we can see that after the starting, he just asked me the first question. So don't worry about the interface. It's a bit complicated, but just to see, I asked him about the age. So he called the age intent, how it's called. The intent is how we say, how we try to classify what the user is talking about. So we can see that he's been trained with some of the training phrases to understand that I'm asking him how old he is. So this seems really straightforward. Here is predefined how I'm asking him, so he should understand, right? So maybe I'll just try to ask in a different way. How old are you? You can see that even though this version of the sentence was not defined to him, he still understands me. So this shows that it's not like a simple search and a predefinition of all the possible questions that I might pose. We are just trying, during the training, we are just trying to convey the information that we'll be talking about the age, and then the language model that's behind the chatbot learns that this question is considering age, and therefore all the similar questions can be evaluated. So it's not bound to only the specified examples, but it's much more wide. And now to the second part, because we can see that he switched the answers. So yeah, if we scroll down a bit, we can see that he has 3 predefined answers to this exact question. So he's just switching through those, but just to showcase how simple it is to modify the flow to your desired answer. If you want to play with the chatbot, try to build something on your own, we can just paste a different answer, just to see if he can reply with that. So again, if I'll ask him again, I need to save. My bad. Sorry. we can see that we received a test answer that we pasted in. So with this simple change of one of the parameters, we changed how the chatbot behaves, and iterating over this simple step, we can design our own questions by changing or adding the intents, and we can design our own answers. So the chatbots will behave according our specific use case. So this was really the really simple example of how you can just use the simple templates provided to you by Google and adjust it to your needs. Because honestly, I usually struggle the most when I have the blank slate in front of me, when I need to do the first step. Once I have something, then trying to tweak it and trying the things around is usually much simpler for me. So with this very simple example done, let me switch to a second, bit more convoluted example, which I'd like to use to showcase to you how simple it is to integrate the chatbot or voicebot that you'll develop here in Dialogflow to other services that Google provides. Because usually, if you just build a chatbot, it's a nice technical demonstration, but it's really difficult to actually use it somewhere. So it can do anything productive other than just being a nice feature popping up somewhere and just answering some random small talk questions, right? So for this, I'll use one of the more advanced pre-built chatbots from Google, which is trained to work for answering as an agent from a call center of a telecommunication company. So again, the flow is simple. I'll just import the template. It should take just a few seconds to once again provide me with Dialogflow. Oh, sorry. And you can see that it's much more complicated this time. It's not just a start page, one answer and end page. We've got the start of the conversation and a lot of branching and a lot of different conversations. You do not need to understand that now. It's not important for our use case. We'll just try to explore one of the paths that you can try to follow through the conversation tree and try to adjust it so it works in tandem with our other functions that we are using on GCP. So for this exact flow, we'd like the agent to offer us a new plan for some roaming across the borders. So for that, he'll ask us, I'll try to explain, he'll ask us where we are traveling and for how long, and then validate against our other source whether he can offer us some of the plans that the company provides. So we do not have to hard code everything into the chatbot, but he can reach out of his little box inside our Google environment and validate against other data. So for that, I've pre-created a simple webhook cloud function. This is out of the scope of the presentation. If some of you are a cloud developer, then definitely we can get in touch and I can explain more in depth what it's doing. But basically, this is not NLP stuff. This is standard cloud development. So what this function does is when it's called from the Dialogflow, it reaches to our database, fetch some data, and return it back to the chatbot. So to use this function, we just need to copy paste its trigger, which basically is its URL, how the Dialogflow will communicate with it, and just tell our chatbots to use it. So in managing of the chatbots in webhooks, I can assign this particular URL which I just copied. And if I save that and go back to the chatbot, right now if I test the agent, he'll reach out to our very complicated database, which I'll just briefly showcase to you. It's a standard cloud spanner database with one particular table, and in this table we've got like 2 columns and a few data points saying that yes, in Italy we can provide some special roaming plan. In China we can provide, in Spain we cannot. So this is the exact table that the chatbot will be reaching out to. So right now, if I start a conversation, again in the test window here, I'll just make it bigger so you can see what's happening. So I'd like to add a cruise plan. So first of all, he just asked me for my number with the company. So yeah, again, this can be validated again against different database using the same procedure basically. Let's say I'm traveling for 7 days, and he offers me some options. So I'd like to take option 1. And now he's asking me where am I heading. So as we saw in Italy, it should be available. So if I tell him Italy, and I'll be spending there 3 days, he'll tell me that it's available in Italy and I'll have free coverage. Right now, if I just scroll back a bit in the conversation, so I do not have to replay it all, and say Spain, because we saw that Spain didn't have the coverage under our plan. So let's say I'm traveling to Spain, and again 3 days. We can see that his answer is different this time. That there is no coverage in Spain, and I will be charged differently. So he offers me to explain further, but again, we are back to the sample chatbot territory. But what I wanted to showcase here was the connection via the simple cloud function to other source of data. So this is the first part. But as you can see, I'm still just logged into the box of the dialog flow. So this is nothing we can present to anywhere outside, right? So we definitely need to deploy the chatbot somewhere. So for showing that, for doing that, it's again very simple. If you want to incorporate the chatbot in some other application of yours, so what I'd like to show is how to integrate it. You can see that there are a lot of pre-prepared connections, but for the time being, I'll just use the sample dialog flow messenger, which is a very simple JavaScript applet that you can just paste into whatever page you have prepared. So for this reason, just for the presentation, I have very simple web page presented in the app engine in Google. So you can see that it's blank right now, and Google logged me out in the meanwhile. Sorry for it. Yeah. So here you can see it's the basic HTML page, just saying that there should be a chat for the time being. So if I just paste the code that Dialogflow so kindly provided to me, I can just paste it into the body of the HTML. And right now, if I just build the application again, deploy. This will take a couple of seconds. Again, this is out of the scope of the NLP presentation, but just to showcase how easy it is, this will now get deployed to the endpoint that I have here, and in a couple of seconds we'll have the chat option here available. In the meanwhile, because this is basically the longest time you'll have to wait, is while the Google does its thing. You do not have to develop anything. One other thing I wanted to show how the whole platform is integrated is that you can have not only develop here, but you can also monitor the run of the chatbots while you deploy them. You can optimize and try to investigate some problems, standard CI/CD pipelines, etc. So for example, here I can see in conversational history, I can see the conversation we had previously when I was showcasing the connection via the webhook into the specific database. We can see that the whole conversation is logged here, so we can fully investigate what happened there. And in case that, for example, I as a customer later on complained that the chatbot was rude to me or anything, we can just simply in the same interface just go back to investigate what the user was saying, what the chatbot was saying, what was the flow of the conversation. So again, really simple, and it's inside the same environment. You do not have to integrate any other services, logging, etc. It's all done here. It's the same as with the Vertex AI, basically a self-contained platform. So in the meanwhile, we can see that the build was complete. So now if I refresh this endpoint, we can see this nice little button. Obviously, that's customizable. And here is our chatbot. And you can see that he responds in the same manner as the one in the testing environment. So yeah, this basically showcases just how simple it is. Just copy paste the applet into your own code, and that's all you have to do. So like to add plan, yeah, and it works in the same way. So this is basically it for the presentation because we are really time constrained. But the main idea was to showcase not some really complicated flows, what are all the stuff you can achieve with this, but just to showcase how simple it is by just few clicks, few other services in Google get from blank plate to deployed chatbot that's actually working somewhere. It took me about 10 minutes while presenting and while trying to explain too. So for the first iteration of your deployment, it's really fast, and with this you can go to the business expert, ask their opinion, and try to iterate over to present a better solution. So let me switch back to our PowerPoint presentation. So this is the end for the demonstration, and now to the coolest and most fancy part, which we are all excited about at this point, and that's generative AI. So first of all, I'd like to ask you a second question. So because we all know that the generative AI tools are now everywhere, most of us gave it at least a try. So we would be curious if you try those, and if you do, what was the result? Whether you were satisfied and saw that just as a nice toy, same as where the chatbots a year ago, and same as where RPA robots 5 years ago, or whether you are using them still, or you actually managed to get some real business value out of those generative tools. So if you can just give us some feedback, so we have some idea what are the real life data, because well, to be completely honest, if any of the generative AI companies tells us that yes, our customers build that many solutions, of course, but that's survivorship bias, right? So we'd be really curious what is your own experience. Okay, so I already have the results in, and actually, majority of you just tried it for fun, but nothing productive, which is actually great because that tells us that there is a lot of space to guide you, to help you use those tools more efficiently, to actually do something productive for you. Of course, it would be difficult to give you concrete example how to make money out of those tools. Sure, if we knew we do it ourselves, but at least use those tools for your own purposes, for your own help. That's definitely something we can help you with. And for that reason, I'd like to give the word back to our NLP expert and our master of generative AI. If you can just step in back, Brandon, it would be nice.
Cool. Thank you for having me again. Long time no see. Cool. If you want to head to the next slide. Excellent, thanks. Okay, so I'll just talk a little bit about what large language models are and why we're talking about them and why they're so important, I guess. And everybody keeps saying that we're having this iPhone moment, right? Just for those of you who aren't actually experienced with these kinds of tools. So these transformer models I was talking about earlier were a huge leap forward in terms of complexity and of the ability to model linguistic data. And then we sort of take that idea and we just expand it, right? We take a model and instead of having maybe a couple million parameters, which are these like little, algorithms, let's say that we have billions, and that's where we come into the era of large language models. So each one of these large language models, which from the Google side is PaLM, Pathway Language Model, or from OpenAI, GPT, which is the one that most people are familiar with, their ability to model language far exceeds that of previous generations of natural language understanding models, like BERT or Word2Vec, etc. And where they fit in the field of AI is really like halfway within natural language processing and halfway within this like greater space of machine learning. Because as you are processing the language data, you actually treat it like a prediction problem. So the way that some of these models are trained is I'll be given a sentence like how old are, and then we take out one of these words and we have the model try to predict what that word is actually going to be. And in this case, the most probable word there is going to be you. How old are you, right? So then you just scale it up to billions and billions of sentences. And what you get is the larger these models grow, the more we start to see what Google describes as emergent capabilities. So instead of just being able to classify a document, we can also generate documents because you run this prediction over and over again. Based on this context, that's my input. Excuse me. Based on my input, it's just going to predict what the next word is over and over and over and over again. So it's not really knowledge. It's not really that the model has like learned something. It's just very good at probabilistically determining what the next piece of the puzzle is going to be. And so that's how we get, chain reasoning, how we get arithmetic out of it, how we get code completion, and all these other tools that we can use in other downstream tasks. So if you want to go to the next slide. Cool. Yeah, so essentially we're switching from input into a model to get some kind of structured output into unstructured input, unstructured output. In some cases, it can be structured. In the case of like using a generative model as a classification model, for instance. So you can literally ask it something like, is the following text positive or negative sentiment? Answer only with positive or negative. And then you get a structured output, which is literally just predicting based on the input whether it's going to be positive or negative. And so the real power of this is that the large language models have many different tasks that they can accomplish with one, what we call like a foundation model. This foundation model is really well adapted to changing the task that it's supposed to actually perform, and which is why we're talking about it so much, because it can be put into so many different workflows, either to automate or drastically reduce the amount of manual effort that goes into actually processing unstructured text data or voice data. Okay, if you want to do next. And so within GCP specifically, what this looks like is that they've integrated the PaLM 2 model, their large language model, with different service offerings. There is a generative AI assistant called Duet AI that's been built into many of their cloud technologies. So even on the side, as you're in Google Workspaces, trying to figure out how to deploy one of these models on cloud, as a person who's never worked with cloud, you can get suggestions and ask questions as if somebody who is an expert on that documentation can actually generate answers for you, give you links to different resources, etc. So I think the real power of GCP is just how quickly they've integrated their large language model into their service offerings, and it makes it accessible for people like me who don't have a whole lot of experience with cloud. Yeah, so I get very excited talking about this. Anyway, next slide, please. Cool. So the PaLM language model at this point is in its second iteration. It's actually a series of models, a whole family of large language models that are different sizes, are capable of different things, and they're trained on multiple languages. So more than 100 languages went into the input for the training data for this model. We don't know for certain that it's 340 billion parameters, which is smaller than the older model, but it was reported by, I think, CNN News or CBS, one of those two. I don't know, the link's down there. But essentially, the way that they've trained it has been optimized so that we require fewer parameters rather than blowing up the size of this model, so that it's more efficient for compute, it's cheaper to run, it has a smaller memory footprint, and it's actually more capable than the previous iteration, improving more than 25% over a lot of the benchmarks that PaLM was given. So if we go to the next slide really quick. The way that we measure the performance of large language models is by using different benchmarks. One of the main ones coming out recently is going to be the Big Bench, what's called the Big Bench. It's a series of tests, and so the Google specific model, PaLM 2, either achieves or exceeds most of the state-of-the-art measurements that we have on the bench test, and also on other like natural language inference tests like logical entailment or arithmetic and these types of tasks. Cool. And with that, I think we've got 7 minutes left, so we can go for a question. Great. So based on what we've talked about today, we're interested in knowing what you guys are most interested in learning more about, and then we can discuss that.
Just one technical note to these poll questions. In contrast to the previous ones, this is multiple answer. So if you enjoyed all of these topics, then don't hesitate to tick all of the check marks, and we'll be definitely glad to have the further conversation with you. So while we are waiting for your answers to the last poll questions, allow me to thank you all for attending our webinar today. I hope that you learned something interesting on at least one of the topics we were discussing today. And if you have any questions, then feel free to either paste them into the chat or try to contact us on our email addresses. You'll see them in the end in the end slide of the presentation, which we'll definitely send your way as part of the follow-up to this webinar. And yeah, I see we have some responses. Obviously, generative AI winning by a huge margin. Was surprised. Yeah, we all love that at this point. So yeah, completely understandable. So that was all from my side. Thank you, Brandon, for attending our webinar. It was really insightful having you here for the hottest topic of today, as being generative AI. and I hope we can see you next time.
Sure, thanks. Happy to have a follow-up and go into a little bit more detail, but thank you for having me. Have a great day.